Okay, well, hi guys. Today we are going to look at how to actually graph linear equations once we have an equation for them by using what we call the table method, by creating a table to graph them. So first, let's just review what we know about what a linear equation is. So we talked about already that a linear equation is an equation that has two variables. So I'm going to put that on here. Has two variables, usually x and y, or we might change the variables to call them x and y. And the important thing about the linear equation is that when you find all of the x's and y's that make the equation true, when you find all of the solutions and you graph them as ordered pairs, the solutions all create a straight line. So solutions form a line when they're graphed. All of those x comma y's I'm going to put on here just to remind us that a solution is an ordered pair. What the x is, what the y is, we put them together and we make an x comma y. So that's how we tell whether something's a linear equation, if it forms a straight line when we graph all of those solutions. So let's look at actually how we graph them. Here's one example, a quick one of graphing a linear equation. Here's the equation y equals 1/3 x minus 1. Last time we practiced finding x and y values, just kind of guessing and checking to find ones that worked for this. And in this case, we're giving them to you. Notice the table that we're doing this time is a horizontal table. In the past, when we were doing this before, we would have done something like, here's our x and a y. So our x and y that go together are -6 and -3. And we would have looked at them like this, as an actual ordered pair. So let's turn this table kind of sideways and look at it as an xy table where we can literally see x comma y. So -6 comma -3, -3 comma -2. This one's 0 comma -1, 3 comma 0, 6 comma 1. We just did number 2. We listed these solutions as ordered pairs, the x's and y's that make this equation true. And if we just plugged one of them in just to test it, let's try this one right here. If the x is 3 and the y is 0, does it make this equation true? Well, let's see, the x is 3, it'd be 1/3 of x. 1/3 of 3 is just 1. 1 minus 1 is 0. And we thought our y was 0. There we go. So we've plugged it in to see that it is a solution. So all of these, we're just going to let you know, all of those are solutions. If we know a whole bunch of ordered pairs, can we actually graph the equation and just determine whether it's a linear equation or not? And let's see. Here's a coordinate plane for you, x's and y's. Let's use our knowledge of ordered pairs to graph these. -6 comma -3. Start at the origin, go down to -6 and up down to 1, 2, 3, -3. There's our dot for -6 comma -3. What about -3, -2? 0 comma -1, side to side 0, down to -1. 3 comma 0, so side to side to 3, up or down 0, not going up or down. And the last one, side to side 6, up to +1. So we've graphed our 5 solutions that we know of. We know there's an infinite number of solutions. Every single point in between all of these on this straight line and going further in both directions is a solution. So it's important that we put our arrows on the end of the line so that we show that it really is not just these points that are solutions, but everything as that line continues. So really, guys, that's how we're graphing linear equations. We just need to find these values on our own and make a table. Once we have a table of ordered pairs, we can graph it and we can get our straight line. So let's go to the next page. Let's just do a couple. This is page 8. So graph the linear equation. Here's our equation, y equals x minus 7. Now this one, they don't give us any table of values for. So we are going to completely make our own x and y. And the trick to this is that we can put in anything we want for x, and we can figure out what the y is pretty quickly. When we don't have any values to start with, usually what we'll do is we'll start out with, what if x is -1 And we'll go from there because we do want to have some sort of idea of what it looks like on the left side of this y-axis. So what if x is -1? What if we plug in -1 to this? What's -1 minus 7? -1 minus another 7 gets more negative. Wouldn't that be -8? So our equation would be y equals, all that would be -8. So when we plugged in -1 for x, we get an answer of y equals -8. So that is one ordered pair. That's one solution. I can put that parentheses and the comma in between them because I know that will make the equation true. We usually try to plug in -1 for x and then try just 0, 1, and 2. They're small enough numbers that we can graph them easily, and if it's a linear equation, we should be able to see a pattern. Every time the x goes up by 1, the y should start going either up or down by a constant amount as well. So what happens if we plug in 0 for x? What's 0 minus 7? -7. All right, there's another solution. What if we plug in 1 for x? 1 minus 7 is all the way down to -6. There we go. What if we plug in 2 for x? 2 minus 7 is -5. Is there a pattern here? When the x goes up by 1, in this case, the y is also going up by 1. It's getting bigger by 1 every time for this particular equation. So if we graph this now, here's our origin. It's a little bit off-center on our grid. -1 to -8. -1 would be 1 over this way, and -8 looks like all the way down here. 0, side to side 0, down to -7. Side to side 1, down to -6. Side to side 2, down to -5. Does it look like it's going to make a straight line? Sure. So let's connect it in as straight of a line as we can. Put arrows on either side to show those are all the possible solutions for this equation. So the hardest thing we're going to do is try and just make these tables. Let's try it with one more. Get a different color here. Go ahead and make on the side your x and y table. And this time we're going to try the same x values. Let's just plug in. Anytime we do this, we're going to try and use the same one so that we can check our own work with each other. -1, 0, 1, and 2. Let's try those. We've got some negatives. We've got small enough numbers that are easy to graph. We know they're near the origin. What happens if we plug in -1 for this guy? So this is a little bit more complicated equation. You might find yourself wanting to show some work for this as they get more complicated. -2 times -1 plus 5. So a negative times a negative is a +2 plus 5 is 7. So we get y equals 7 for this one. When we plugged in -1, we got y equals 7. So I'm going to do the same thing but plug in these different ideas down here. My next one, instead of, let's see, y equals -2 times 0 this time, I'm plugging in 0 plus 5. So -2, anything times 0 is just 0. That kind of goes away. And then we just get y equals 5. So when x was 0, y equaled 5. Those are the two values that make the equation true. Let's try another one. Let's see what happens when x is 1. So -2 times 1 plus 5. Negative times a positive is a negative, -2 plus 5. I'm keeping my y equals there. And -2 plus 5 is 3. So we plugged in x equaled 1. We got that y has to equal 3 for it to be true. And then our last one, -2 times 2 plus 5. So that would be -4 plus 5, which ends up being a +1. So now that we've got our table, I could put them into ordered pairs like this. Let's graph it. Let's see if it makes a straight line like it should if it's a linear equation. So -1, 7. Oh, this is not a good graph for this one. Okay, guys, here's what I'm going to do. We're going to skip number 3, and we're going to go down, and we're going to use this grid for this one because it actually has room for it. So -1, 7 would be over 1, up 7 here. 0, 5, side to side 0, up to 5. Side to side to +1, up to +3, and then our last one is 2, 1, over 2, up 1. Does that look like it's going to make a straight line? Sure. So let's connect those dots the best we can. Put arrows on either side to show that those are all solutions that will make up here this equation true, even though we used the wrong graph for it. Okay, so we are going to actually skip a couple of pages in here. We'll come back to do some more notes. We are going to look at your assignment, which is page 10. And let me show you how to do a couple of these on here. This one is another riddle. How does the average man feel today? And it says we're going to actually make our own tables. They gave us an X to plug into each equation to get what the Y is that would go with it. And then we're going to graph the solutions and draw a line through them. And once we draw that line, it's going to go through one of these letters. It will cross one of the letters, and then we'll know what to fill in over here. So number 1's either going to be C, T, or K, and we'll have to see where the line hits. So let's see if we can do number 1. The idea is that this is our equation for number 1, y equals 3x minus 2. If you can do this mentally, accurately, awesome. If not, grab another piece of paper to show some work, or you can fit your work up here along the top or anywhere you can on here so that you can make sure you're not making silly mistakes, especially with negatives. So this time they're giving us values of x to plug in. What would happen if x was 3? Can we plug it in, plug it in? 3 times 3 is 9, minus 2 is 7, so y would equal 7. When we plugged in 3 for x, we got 7 for y. Let's plug in 2 for x. 3 times 2 is 6, minus 2 is, I got 4. Now negative 2, 3 times negative 2 is a negative 6, minus another 2. I'm just going to write it down so I don't forget these. Negative 6 minus 2, negative, and then minus is going to get more negative. That takes us down to negative 8. And then 0, I like 0. It's pretty easy because when you plug in 0, 3 times 0 is just 0. That all goes away. What's 0 minus 2? Takes you down to negative 2. So it's up to you whether you want to turn these into ordered pairs or whether you can just get used to reading them from the table, 3, 7, right here. Let's graph them and see if it's a linear equation. So 3, 7, now these aren't numbered, but we can count. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 2, 4, 1, 2, 1, 2, 3, 4. Negative 2, negative 8. Okay, so negative 2 is this way, or the negatives. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And then 0, side to side 0, down 2. Okay, do those look like they're all going to make a straight line? Yeah, they do. So I'm going to connect those. If something happens on here and you got a dot that was up here, one of yours was way up there and clearly was not in line with the others, you'd want to look at that one and go back and do your math again and see if you just made a silly mistake, especially with those negatives. So what we want is we want them all to make a straight line, and they should, like this one, go through a letter. So number 1 is going through T up here. So that means that over here in our riddle, number 1 is T. Okay, so now the only downside, guys, to doing kind of some random numbers that they give us is that we won't be able to see any kind of pattern in the Y's this time. So we'll just have to kind of trust our math, graph it, and see if it looks like a straight line there. Let me go down and look at number 6 with you. I'm going to skip down to 6. This one, for some reason, freaks some of you guys out because you start seeing a fraction in there. But if you look at the numbers they give you good numbers for this fraction. So this might be one you want to show some work on. It's up to you. Let's try and plug these in for x and see what we get. All right, so negative 2/3 times 3 for this one. I'm going to write it down. Negative 2/3 times 3. Well, guys, isn't that like times 3 over 1? Right? When we do this, we would get negative 2 times 3, which is negative 6, and 3 times 1, which is 3. So we just get negative 6 over 3. What is that? It's just a negative 2. They gave us nice numbers that are going to simplify into some whole numbers here. So I've still got this plus 4 at the end, this plus 4 that I don't want to forget about. But really all that is negative 2 plus 4. Negative 2 plus 4 brings us up to positive 2. All right, let me do one more with you, and then I will let you figure the rest out here. How about if I do 6? All right, let's plug in 6 for x. Y equals negative 2/3 times 6, and then still this plus 4. So I'm going to make this times 6 over 1. What would that give us? Negative 2 times 6 is negative 12. And 3 times 1 is 3. So what's negative 12 divided by 3? 4. Negative 4, right? So negative 4 plus 4. Negative 4 plus 4 is just going to be 0. So let's just try and graph these two, see if they look like, well, they're definitely going to look like they make a straight line. 1, 2, 3, 1, 2. And 6. 1, 2, 3, 4, 5, 6. Oops, 1, 2, 3, 4, 5, 6, and 0. All right, we've got to do 2 more, see if they fit on that straight line, and then see if we're all good with our math. So I'm going to let you finish that one on your own, and then you guys are going to do the rest of these, and that is the assignment that is due for you on Monday. So you can work on that for a little bit, and then hopefully you'll also have some PLT time later on today. All right, I'll see you guys later.